Well, welcome. Thanks a bunch for coming out this evening. I just plan to, the agenda for the evening is to take 10, 15 minutes. I'll introduce the Insulating Concrete Forms system. You see that ARCS is the brand that's on your answer book there. ICFs in general, lots of things play out for most ICF manufacturers. So as far as AIA is concerned, generically insulating concrete forms are insulating concrete forms. It's a matter of who provides better technical support, who's got the expertise to support you in your design. So since to get that out of the way, I want to introduce insulating concrete forms for a number of reasons. You guys are constantly looking for new ways to design your buildings, either with the standard ways that you have for years, or looking for new ways to set yourself apart. So insulating concrete forms offer you a way to do both of those things. The key is that ICFs provide you structure, insulation, furring strips, attachment points, strapping, and air barrier all in one step. And I also do want to introduce to you our commercial construction manager, Andy Horgan, is ARC's commercial construction manager, and Umberto Mendieta and Robbie Vernelson. These guys are foremen for the installation crew here. They're 2 of 10 guys that are putting up the exterior walls in this building. 1 crew for the exterior walls. So when I talk about structure, insulation, furring, and air barrier all in one, it's just 10 guys that are doing that exterior wall assembly. So your building envelope it's continuous insulation on both sides of the form. This is a standard block here, 4 foot by 2 foot. It basically works like Legos. You've got interlocks that the blocks attach together with. And on the inside of the forms, you see everywhere you see one of these metal grates, you've got a steel tie here. Okay, so these steel ties, the expanded polystyrene on both panels is actually blown around these steel ties in the manufacturing facility. So this form comes pre-assembled to the site. Okay. These ties are, in this case, this block is 24 inches tall. The steel ties are 21 inches tall, so that and they're placed equidistant in the form, so that when you stack another form on top of here, you'll actually have 1.5 inches space here and 1.5 inches space on the next block, so that you have 3 inches of unobstructed space in that foam through which you can route and channel your conduit or utilities. So the conduit and utilities actually runs in the thickness of the foam. There is no need to fur out for additional framing on the inside, because your insulation, your furring are inherent in the forms. Okay. So since only 10 guys are installing the walls out here, that means it's a smaller crew. It means less opportunities for safety issues. And since the forms are 9 pounds, it takes the place of 9 CMUs. So 9 pounds here, whereas it would be something like 128 pounds worth of CMU surface area. So the safety of installing the form is also of value there. There are a couple of benefits that the architects are going to discuss with you. One of the reasons why it's gotten some attention recently, insulating concrete forms, is its energy performance. You've got an R22, a nominal R22 insulation on collectively, 11 on either side. When you factor in the thermal mass of the concrete, and also because it's a cast-in-place system, that makes it inherently a tighter wall. So when you factor those 3 in, insulation, air infiltration reduction, and the thermal mass, you get a wall that performs higher than its nominal R value says that it will. Okay, and some other benefits, and your answer book is, you're free to flip through that if you would like. If you look at page 8, in this building, it was not used as partition walls, but there are settings where it does well as a partition wall, both for fire safety and for sound attenuation. So if you got STC of around 48 to 53, depending on what is on your forms on both sides, you've got superior sound attenuation. And it's a 4-hour firewall without putting anything on it. So where you need to separate between sections of a building, you need that firewall safety, and ICF plugs right in there inherently. Okay. Just briefly, on page 10 and 11, you see some installation procedures. Basically, you're starting out with a fairly standard footing, and you're going to glue, I think, where did I go with that glue? Right behind the two gentlemen in the orangey shirts right there, there's a red can above. And that can holds a good deal of urethane foam, and that foam is actually used to glue the forms together, but also to fasten it to the footings. And that foam is strong enough to hold those forms on the footings for during the concrete pour. Okay, so you're placing that on a footing. It's a foam form, so it's tremendously easy to cut and manipulate. And the architects also talk about how the system has been able to fit what they are doing structurally, and design-wise, it's flexible for their needs there. I brought an example of the window and door bucking, and this is called V-buck. It's a vinyl buck. It's actually 100% post-industrial recycled content, not post-consumer, but it's post-industrial content. And this form stays in place to block out for the window and doors. And it comes in 16-foot lengths. You cut on either on site or in this case out here, the V-buck manufacturer actually cut all the pieces to length so that was a step that wouldn't need to be taken on site. So they can just pull the piece off the pile and assemble the openings as needed with these connector pieces. It's designed for insulating concrete forms. Flanges reach out over top of the form so that the surfaces are smooth and clean. Okay, and of course rebar is required according to the structural design, and so your engineers will. It's a cast-in-place concrete wall. It's just an alternative way to cast a concrete wall. The forms just happen to stay in place. Okay, so rebar is fairly standard according to the needs. You won't see any of the bracing out there. They've just poured on Monday, and so they've disassembled bracing before they move on to the next section on the south wing here. So you can see that small picture there that shows you ICF bracing systems. You've got an aluminum channel that runs on the wall, a diagonal turnbuckle that fastens to the ground and is easily adjustable even during and after the concrete pour to make sure that the wall is plumb straight. And it also carries scaffolding, as you can see there. Since it's a foam form, you can run sleeves straight through it for your utilities to run in. You'll see plenty of examples of that on the outside wall. Here, even some massive steel manufactured plates that were needed to be in that wall. They were able to cut the forms fairly easily to do that. And then the last two are running conduit. A hot knife or an electric chainsaw is going to run your channels in the foam. And that thickness is able to allow the thickness of the conduit to reside in there. And finishes. Any finish you want can be attached to the outside or the inside of the form. Since, what happened to it? Yep. It's an 1.5 inch wide cold form 22 gauge steel stud, a 1/2 inch buried below the surface, every 6 inches in this case. So any fine thread screw, self-tapping screw is going to come right through there. To fasten your drywall or masonry ties in this case out here, or siding, stucco, lath, etc. So, and that can be applied directly to the surface. Okay. So what I'd like to do is pass the buck on to Derek and Sarah, so they can talk a little bit to you guys about why they selected insulating concrete forms for this particular project and how it suited their needs and the benefits that it provides here.